Good afternoon, everyone. It's a real honor and privilege to be here to share this exciting project. It's a project around using simulation model in a kind of a unique way. We've already heard this afternoon about using simulation models for predictions. This was specifically around the gas turbine manufacturer and what happens when you get some kind of early warning that things might be going wrong. But before I do that, let me give a quick introduction about our company. We'll share the agenda, and then we'll get straight into it. Golden Research Labs, we are really passionate about helping individuals and organizations make better, faster decisions when it really matters. And often it boils down to helping them answer two simple questions. How much better can you do? And how best to do it? What's the simplest, fastest, lowest cost, lowest risk way of doing it? When we think about how much better you can do, normally we get two types of customers that approach us. Ones that are not doing okay, and they need to do better and quickly, else there will be severe consequences. The other one is they are doing okay, but they want to know if they can do much better. But there's a third type of customer that says, we don't know if we are doing okay. Is it going to be okay? And if not, what can we do to save it? It's kind of, I want you to imagine a very simple story that will be an introduction of the type of project that we're doing. You've got an important meeting that's going to be starting at 2 o'clock. You've got 60 miles to travel. Speed limit is 70 miles an hour. When do you leave? This is your first decision that you have to make. What you know, because you've traveled this highway before, is that you can do about an average of 60 miles an hour. So you should really give yourself about an hour to cover the 60 miles. Now you are hitting a milestone, which is a 20-mile mark. And you have a look at your watch, and it's taken you 25 minutes rather than 20 minutes to cover the 20 miles. What do? So immediately things start racing through your mind, right? If I could get back to driving at about 70 miles an hour on average, because that's my speed limit, I can cover the remaining 40 miles in about 35 minutes, so I should be okay. Right? But I don't know, is this just an early warning that actually I'm going to be losing 5 minutes every 20 miles? So I'm going to be 15 minutes late. Can I catch up? I don't know. These are the type of real-life situations that managers and organizations face today. And what we know is even though these environments are deterministic but not predictable because they are mostly chaotic, they are predictable to a level of good enough. So in this little story, what is good enough? I need to know, am I going to be early? So stop panicking. Am I going to be about on time, late or very late? And if I'm going to be late or very late, is there anything I can do to change it? Do I need to phone the customer and apologize and say I'm going to be late or change my commitment? That's a type of problems that this project is an example of. And what we wanted to do is we had started working a few years ago, and we have presented before at AnyLogic, of building simulation models that can be reused, completely self-configurable from data. We've done that in supply chains. We've done it together with Amalgama and mining. And this was a challenge. Could we do it in a project environment? So I'm going to just give a quick introduction of the project. I'll share with you what the main business challenge was, so you already have a hint about the type of problem that this management team was facing. We'll share a little bit why simulation, and specifically AnyLogic for this project, and then we'll do a quick demo of the model itself, and I'll share with you some of the results that we've achieved. So the background is one of the largest gas turbine manufacturers in the world, and they were facing a real problem. They had about a 5-year portfolio of gas turbines to make, and they were about a year or so into this, and they were starting to get signs that they are starting to deliver late on certain commitments that they've made. Do we need to panic? Yes or no? Are we going to be on time? We have quite good margins, so they were planning at about 30% net margins. If we need to, can we throw money at the problem, get additional resources and catch up? Or is it simply not possible? What's our best option? Do we need to change our commitments to our shareholders and to customers? And they were specifically worried about the backlog that was starting to build up. The sales team had gone out there. They had developed a strategic competitive advantage around reliability. They were so confident based on their past performance that they were willing to offer penalties for late delivery in return for bonuses for early performance. And they were starting to get really worried. Even though they had good planned net margins of around 30%, they just weren't sure what was going to happen. So the idea was we had already started developing a model that was completely self-configurable, that you can literally do a download from MS Project or any other project environment with a full work breakdown structure, all the resource allocations, the interdependencies, the times, and then of course you introduce the variability around those times, etc. And we wanted an environment to test, and this was an ideal environment to say, can we use the simulation model, read in the full project plans that they've got for their whole portfolio of programs with clear milestones and key deliverables, and essentially press the play button. We have created a digital twin that's going to help them to check, are we going to be okay, yes or no? And if not, by how much are we not going to be okay? How late are we going to be? And what's the financial and operational impact as a result? We know that it's a major challenge for any manager today because not only we have to make tough decisions, we have to make tough predictions. And why is it so tough? Because we have to commit to lead times, to budget, to scope. And it's extremely hard to do this when we are looking at the VUCA in these environments. Lots of volatility, lots of uncertainty, lots of complexity, lots of constraints, and ambiguity around what are the main target objective functions. Are we going to go after time? Are we mostly interested in scope or budget? What is the combination of these? And then on top of that, we know that these systems are nonlinear by nature. Big changes could have very small impacts. And very small changes can sometimes have big impacts. The current tools that they had, their Microsoft projects, other project planning systems, their ERP systems, and others were simply not capable of answering these type of questions. And they needed to come up with an answer and do so very quickly. Why simulation? Because we can build a digital twin that's at the level of good enough to be able to give us that kind of magnitude of answers. We've been trained that it's better to be approximately right than precisely wrong. We wanted to give them a model, a digital twin of their environment that would help them to be approximately right. Are we going to be early? Nothing to panic about. You've just had a bit of a delay, but you'll be able to catch up. There's enough buffer in the system. Or you're going to be about on time, or you're going to be late or very late. And what's the financial impact of that? Are you going to make about the profits that you estimated? Are you going to make more, less, or a lot less? They simply didn't know. Why AnyLogic? We've been using AnyLogic for many years after evaluating a whole range and playing around with a whole range. And as previous presenters have said, for us, it's the best tool to model real-world complex environments. It allows us to mix up all the modes of logic. It allows us to get models out very quickly, test them with clients, and build beautiful user interfaces to make these models believable and usable. What they approached us, when this client approached us, they said there's some early warnings that they're starting to run late. They are thinking about introducing a new project management methodology, which was based on theory of constraints called critical chain project management, very similar in terms of principles like Agile and Scrum, fast feedback loops, making sure you don't have too much stuff that you're working on at any point in time. And what we wanted to do is to show them what will happen using this digital twin that we've built from the environment if they don't change the project management practices. So what we noticed from the plans that they gave us is everything was starting as soon as possible. And the later they were going, every new project that was being launched was being started as soon as possible. And this is in very much contrast to the principles of Agile and critical chain project management of staggering the release of projects, starting as late as possible. The big challenge that they didn't know was how much WIP in the system should they tolerate. They had a portfolio of thousands of phases that are all required to make up hundreds of projects and about 100 programs or so. What was the work and process limits that they could use to limit the amount of multitasking that was going to take place? Because we know that there's too much when everybody's just chaotic. There's multitasking. You're being measured on how many things you are starting, not how many completing. Everything takes longer. You get much less done. But there's also too little work in process, where you're starting to starve critical resources in various locations. They simply didn't know, even the most experienced experts in critical chain didn't know what these WIP limits could be. And we said to them, you don't have to guess. You can use the model to run sensitivity analysis on this parameter and determine what is the best work in process limits for your environment. The second question that I had was, how do we control WIP? Do we control it at the task level, at a phase level, at a project level, or program level? Each of those have got pros and cons. How do I decide which one? Again, we said to him, you don't have to guess. You can run all these scenarios and we'll see. And that's what you'll see in the scenarios that we ran. We ran a baseline scenario that was based on following traditional project management rules. That includes traditional pipelining, start everything as soon as possible. It included traditional buffering, which means every task, every phase, every project is protected. It doesn't use aggregation of buffers. And as a result, you waste a tremendous amount of the safety that you've both added in terms of time and cost. And lastly, traditional execution is all about everything goes red quite quickly, and then how the hell do I prioritize? Right? We leave it up to the local areas to decide. Compared to saying that we have some mechanism that will determine for us what the priority is from a systems level. In critical chain project management, we use this thing called fever chart, which is measuring the consumption of the project buffer and comparing that to the progress that you've made. If you're consuming the buffer slower than what you make progress, you're okay, it's in the green. If you're consuming your buffer both in time and cost faster than what you're making progress on your critical path, you're not okay and it's red. And immediately the whole system, that task that they're working on has a clear color level, and they just follow the colors. So the objective here was we wanted to use this as an example to test this platform that we've developed, completely self-configurable digital twin of a project environment. It doesn't care what the nature of the project is. We've tested already not just on gas turbines, we've tested it on banking, IT projects, we've tested it in construction. You read in the full work breakdown structure as a direct export from the project management system. You add in all the volatility and variability, the cost elements, and the model automatically configures itself. As I mentioned, we had 4 scenarios that we're going to be running. The first scenario was, you've got this pipeline of 5 years. You're about a year into it. What's going to happen if you don't change the rules that you're using to plan and execute projects? And you can imagine the high drama of presenting in front of the board and pressing the play button and them not knowing what's going to happen. And they see the clock running, and it's starting to approach this 5-year where everything had to be completed, and they're starting to see some of the projects and programs are starting to run late, and they're incurring penalties. There's no early bonuses, and that little 30% net margin was being consumed faster than what they had ever expected, and they don't know what's going to happen. You'll wait until the end after we've done the demo to share with you the results of what happened. So I'll hand over to Jaco-Ben, who will just quickly take you through the architecture of the model, show you the model demo, and then I'll get back and show you the end results.
Okay, so first up to set up the model, we start with a work breakdown structure from something like MS Projects. So we've got 3 levels at which you can manage your portfolio of projects. The highest level is a program, and a program consists of a number of projects, and the projects inside a program are independent from projects in another program. Projects consist of phases, and on a phase level you can assign resources, number of resources, the duration, as well as the dependencies of one phase on another. These then get exported to Excel, and we allocate additional sheets to the Excel workbook, which is the locations for the resources, the resource availability, the cost per day, as well as the financials for completing the different phases. Late completion penalties, early completion bonuses, as well as a distribution of the planned durations for each phase. We then take the expert's opinion based on the variability and uncertainty that you'll have for these different phases. These all get imported into the AnyLogic model, where we make use of the different scenarios, and you can set up what would be the WIP limits on your projects, on your phases, on your programs, and together with a theory of constraints, best practices of critical chain project management, we can then run multiple scenarios where we model task switching and multitasking in the traditional project management environment, the prioritization that we can follow in the different scenarios for CCPM, the resource allocation, the bonuses, penalties, etc. The outputs of the model is then the reports that you get in AnyLogic, where you can compare in the different columns the different scenarios. There's also detailed Excel reports, as well as text logs if you want to deep dive into the specific project or specific phase execution. There's three ways to run the model. Firstly is the single run, where you can view the actual work breakdown structure in Gantt charts. There's sensitivity analysis, where you can play around with the number of projects or programs or phases in WIP, as well as scenario comparison. So a quick demo of the model. If you start off on the home page, there's three ways that you can run the model. You can run the scenarios one by one, which will guide you through the steps indicating what was changed for each scenario. There's also a scenario comparison functionality. Here's just quickly showing you the import from Excel, so very simple, the resources, number of resources per location, the detailed work breakdown structure where you define the resources required, the prerequisites, cycle times. You can create a priority schedule for each one of the programs. Here's just showing the step-by-step instructions where you can see the work breakdown structure. You can click on every phase, which will give you the detail, when was it planned, who was supposed to be working on it, the resources. We've got the fever chart on the left-hand side, where you can see the progress of each program as it's consuming its buffer versus the percentage of the critical chain that's been completed. There's a bunch of other performance charts which we can quickly view. So the nice thing about this is, as Alan mentioned, it provides you with this digital twin environment. We can see here 4 years of execution, line by line, phase by phase in this Gantt chart. We can see when a project was likely to be late, when a program was likely to be late, when a phase was started, when did it start consuming, the full buffer, when is it running late. We can see the impact of multitasking. So it really provides project planners with a detailed view of what might happen. You can see how the fever chart, how the different programs progress. We can see the resources by location, how much time is lost due to multitasking, how much time are they idle or busy. We can see the work in progress, throughput, some financial parameters, and this is really interesting because we can show the profit impact of starting all these projects so early, consuming all these resources, paying for them, and in the end actually having a very bad cash flow. We've got detailed analysis of all the resources. You can see what resources are being overloaded, when, what's the demand on each resources versus the time available. And you can also view each individual resource by its location. So just running to the last part of the model, you can see how the profit only picks up towards the end of the portfolio life as you start completing all the actual results. And we'll go through the results in detail just now.
Thank you, Jaco-Ben. As I mentioned, so imagine this, we were given 8 weeks to prepare this simulation. We're working very closely with Andrei Malikanov and his team, and now we're at the point where we are presenting to the board. And it's high drama. You can imagine the people that planned these projects, made commitments, both operational and financial, were sitting there now waiting what's going to happen. You'll see on the results here, 20th of January 2022, was the expected completion of the full portfolio of these programs, projects, phases. They were expecting to make around $128 million of profit. It's about 32% net margin. So the sales and financial people were saying there's a lot of money here, right? If we need to catch up, we can throw resources at it. That's how we normally save these projects, and we still end up with about 10%. And the question was it enough? So we ran the first scenario, which is just following traditional project management, not changing the way that they plan and execute projects. And the results were not good at all. They ended up being over 2 years late, finishing 15th of February 2024. Rather than making $130 million, they lost $181 million. As I mentioned, we're not trying to be precisely wrong here, we're trying to be approximately right. Are you going to make about the money that you expected, more, less, or a lot less? And the result was very clear, a lot less. And now the question is, can you do better? Is there anything that we could do to be better? And that's why scenarios 2, 3, and 4 came in. Even for us as the most experienced theory of constraints experts and project environments, we weren't sure what the best rule was to control the work and process in the system. Do we control it by project level, which is scenario 2? Do I control it by program level, which is scenario 3? Or do we use a hybrid? We control it by program level. We release program for program, only release a new one once another one has been completed. But we have a hybrid that says, if we notice that there's one location with a lot of resources that are now completely staffed, let's launch some additional projects to keep them busy. And the results were immediately very positive, is that we showed that you could, in fact, even though you're still going to be late on the total portfolio, you can actually make about $105 million on this. Despite being still a little bit late, you're going to be finishing in October rather than January. The big thing for them was, this is a swing of $286 million. That's massive. So the question was, can we do even better? So we tested it with scenario 3, which is controlling it at the program level. And we found out that, yes, this would make them profitable at least, but it's not as good as the previous scenario, which is only at the project level. And then the last scenario was a kind of a hybrid. We were hoping that this would be even better. It turned out that it's better in terms of lead time. So you can see here, this is 671 days earlier than the scenario, the baseline scenario. But the financials weren't there. And what we realized is that the penalties and bonuses are not equally distributed. And we could run multiple scenarios that says you are going to get very good indications which projects are going to be late. So if you reprioritize, you can make sure that those that have big penalties or big early completion bonuses, that they are on time or early. And that gave them even better financial results. So that's how we ended up. What we've ended up with is now a digital twin for any project environment. You simply make an export out of whatever project management tool that you are using. It gives you your full work breakdown structure. You add in all the additional details that might not be captured there, like the variability in lead times, the costs, the bonuses, etc. And then you read it in and you've got the digital twin of your environment. So we'll end up here. It's been an extremely exciting project. We think that there's a lot of potential in exactly answering the type of question that I started with, right? Is we suspect that things are going wrong. We're getting early signals that we're going to be late. Do I need to panic? And I don't need a precise answer. I need to know, am I going to be early, on time, late, or very late? Am I going to make more money than I planned, about what I planned, a less or a lot less? And that's kind of the level of accuracy that we've seen that these models are capable of predicting. So thank you very much for the opportunity, and we'll open it up for questions. And again, a big thank you to my team, Dr. Andre Malicano from Amalgama and Jaco-Ben for helping prepare this.
Hi, it was a wonderful presentation. Did you use something like an Bayesian network to understand the probability of failure, or by probability by which the changes might have happened?
No, we used something much more complex called human intuition. So we called in everybody on the project teams. We had conference calls with them to say, you know, your original plan said 20 days for this phase or for this task. What's your expectation? Based on your experience, right? As we didn't know where in the probability distribution that number is. We wanted to capture that into the model. And I said, look, the fastest, if we have a full kit, we have all the resources that we need, we can probably get it done in 10 days. But it could also take 60 days. So 20 days is a kind of a likely number. So we were using their intuition to tell us what the variability was around that and allowed the model to tell us what the implications were depending on where it ended up. So we could run multiple permutations and generate a range of impacts. As I mentioned, the ones that we showed was to say the whole range of impacts for the traditional project management methodology was all losing a lot of money. And all the ranges for the other options was making more money or a lot more money than what you expected.
This is such a complex project. Don't you think something like a conditional probability might have helped you instead of the intuition of some managers maybe?
I think there, again, it's the design philosophy is here. We're trying to be approximately right. And you have to do it in a very short period of time. People just don't have that data or knowledge about it. You want to capitalize on their intuition. Some of these people have been building gas turbines for 30 years. They know the range of possibilities. They just have never been asked to give that range of possibilities. They're asked to commit to one number, and you just don't know where in a distribution. So we try to keep things really simple and practical and show the implications of that. Great.
In your output report, do you consider or have you look at the confidence intervals and see, because confidence intervals can help you decide whether one option is better than the other. Right now, you're just reporting the average.
Yes, absolutely. So we ran a range of simulation outcomes to see what the outcome was. And we didn't just stop there. Because of the limited time, we only stopped here. But we tested a large range, and there was many things that we had, including myself, that have been doing this for a long time. We were surprised because these results are nonlinear. Often you think, wow, if we added resources in this area, it will make a big difference, and then it doesn't at all. And we even had situations where adding resources would cause the whole thing to not just cost more, which is obvious, but actually take longer. And that to me is the exciting part of building these digital twins, is being able to test this nonlinearity and see it in action. Of course, one of the upsides or downsides, depending on how you look at it, was this team suddenly said, we really shouldn't be making any of these big decisions without having a digital twin of our environments.
So Jaco-Ben mentioned that you're loading the schedules, the various project schedules from the portfolio at the portfolio project and then phase, I think. So is there a built-in sort of native limit to the level of detail of those schedules?
Yes, of course, it depends on the size of Excel. And then if you're using something like Python, there isn't. But what we asked them to do is to give us the lowest level is where they allocate time, resources, and budget. And in their case, it was phases. But you could go down to tasks. We don't normally recommend that because it's creating a lot of very often artificial interdependencies that's constraining the system overall. So we like to leave it at the phase level. Thank you very much. Thanks.